Okay, without any further ado, we'll move on to the next session, which is another farmer panel session, which is great. So again, this will be facilitated by our chair, John Ferrier. If I could invite up Tim Reethus, who is one of our BCG board members, and Tim McClelland. We're going to have a discussion around, decision drivers for selecting seeders. So thanks, Tim and Tim. And I'll hand over to you, John. Thanks.
Good. Thanks, Fiona. And welcome to Tim and Tim, and thank you for giving time to talk about probably one of the most critical things that we do is actually getting the seed in the ground. And there's always plenty of discussion about time, but really probably following on from the trials that we had out at Barber's farm in 2020, I think it was, where a number of seeders were trialled against one another, some tine machines and some disc machines, some precision discs, all sorts of things were trialled out there. And I don't think a lot came out of it. The fact is that how well you set up your seed is highly critical to the germination of crop on time. So welcome Tim and Tim, and we might start with Tim Reethus first. Yep. Tim, just tell us a little bit about your operation and where it is, and I know that you're now using disc seeders, but when was the last time, could you just also tell us, Tim, when was the last time you had a tine machine on your farm?
Yeah, I think we had a tine back when we had the horses. No, no, not that long ago, around 2000. So Dad was a pretty early adopter of minimum till, so he had his knife points in pretty early. I remember him on the FlexiCoil, having to change lots of them. And then, we moved into a daybreak disc system in 2000, and that's where we decided to go controlled traffic. At the time, the narrowest you could get them in one gang, which is what we wanted for access, was 15-inch. So forever after, we are locked on 15-inch, and the bar was 40 foot wide, so we're locked on 40 foot. We'd love to go metric, but that's not going to happen because we've done it for 20 years this way. And that's because that's the only way the machinery came. So we had that, and then in about 2016, we had an opportunity to buy a precision planter. So we bought a precision planter, and we ran that for a couple of years and learnt some stuff. And then about 3 years ago, we bought the big machine, which was a combination of what we'd learnt from everything previously.
Tim, we might just continue on there. When you say you learned some stuff, what did you learn?
Well, the disc seeding worked for us because we wanted to get through the residues that we had when we were minimum tilling. But then what we were finding is that the soil's becoming softer in our area because we're down at Horsham, Kalkee, Narrabri country. And even in the harder ground, they were getting softer and the discs were actually starting to stall. So they were actually not spinning. They were just getting bulldozed along because we're trying to sow shallow because we want to catch that first rain event to get the crop up. And because it was stalling, we had to do something. We tried the precision planter. It had 2 discs which are together in a wedge. And that worked really, really well. And we were really happy with it. But the precision singulation, everything was probably overcomplicated for what we needed to achieve. So we got the new bar and we ordered a bigger one. So it's 24 metres, so 80 feet. 80 feet bar, single gang. We use row units that are just like a precision planter, but without the metering boxes. So it's just adapted to be an air seeder. And that sort of kept us in the disc game, kept our minimum disturbance thing going, and more positive traction and much better depth control because each row unit can be controlled independently from the cab. They automatically adjust to downforce. So, seed bed accuracy.
Thanks, Tim. Tim McClelland, could you just tell us a little bit about your operation? And you bought a seeder 2 years ago, I think? Was it after?
It's done. We've done 2 seasons.
Just give us a little bit of a brief picture of your operation and the machine that you're using at the moment.
Sure. Mixed farming enterprise with sheep and cropping between Birchip and Berwick. Farm with my dad, my wife and my aunt. And in 2 years ago, we've done 2 sowings with it. We've had a Horsch seeder, a Sprinter with a 21,000 litre air cart. With a knife point and press wheel system and coulters on the front as well.
So what process, Tim, did you go through to choose that machine? Because lots of machines on the market, lots of talk about this and that's best, this is better than something else. What was the tipping point to go to the Horsch?
The tipping point was that we were running a smale bar and the efficacy of the seeding was deteriorating. It was coming up uneven. There was one gang that was always later to germinate than the others. It just wasn't quite working for us, so we needed to either spend a lot of money to fix it up or look at a new seeder. So the process that we went through is that, we wanted to be able to get it serviced locally. So that meant looking at the dealerships in the district, and that got us down to 5 different brands. And then from there, we going back 10 years ago, we were on 7-inch spacings, and then we moved out to 9, and we wanted to keep as narrow as possible. And so a lot of those 5, only 2 of them were capable of going to 10 inches. So that meant that we were down to a choice of 2. And then it came down to looking at maintenance and those kinds of things to help us. It sort of swayed our decision in the end. We went with a Horsch in the end because our perception is that there was going to be a lower maintenance requirement on that than the other one that we didn't go with.
So Tim, I understand that maintenance of these machines was also a factor when you bought it at all. Why does it need so little maintenance?
So a lot of other machines have a hydraulic ram sitting behind the tine, which is giving the breakout pressure. The way that the Horsch system works is that they have, it's basically a steel clamp that goes around the outside of a boxing frame over the top of the frame with rubber strips going through. And the rubber rolls act as that, provide that pressure, and if it hit a rock or hit something that's a bit firmer, it flexes up and moves with the soil that way. So based on that, we don't have bushes, we don't have as many hydraulic hoses to be dealing with in terms of maintenance. All of the coulters and the press wheels are in what's called an oil bath, which means that we don't have nearly as many bearings to be replaced. On our old seeder, we'd pretty much replace 1/3 of our bearings on our press wheels every year, just because dust's getting into them and them wearing out. So after 2 seasons, we have replaced 1 press wheel, which was faulty and it was under warranty, but the rest of them we haven't had to change a bearing in 2 years of seeding.
So one of the critical things, Tim, in getting crop establishment is getting through residual stubbles and straw. And how does the machine cope with high residue stubbles, the crops that you grow out there?
So in 2019 we had a nice hybrid canola crop, wheat direct head, and so we had stubble really high. It was a bit less than a metre probably. So that was the one where I thought we'd probably have some difficulty in getting through it, but with the coulters on the front, it really it went through no problems. I was worried about that, but it ended up being fine. For the whole of sowing last year, I think I probably had to do 10 360s just of a little bit of residue build-up, sowing through barley and wheat stubbles and those sorts of things, coming out of one of the best years we've ever had in 2019. So if I can get through crops in 2020, residues in 2020, then we should be able to do it indefinitely from here.
And Tim Rethus, your disc machine would sort of take on any sort of stubble, I presume, but what are the issues in getting really good seed placement with high stubble load and using a single disc?
In a single disc it'll help push out of the way a little bit, but you'll get more soil throw. But with the twin disc, the biggest issue is that you have a gauge wheel that catches the soil as it's thrown off the disc, and that stops it throwing and jams it back in. So you don't end up with a furrow at the end. It's dead flat, or actually slightly proud by the time the closing wheels have gone through. So from a point of view of the biggest concern is pinning, because if you've pinned it, you haven't moved any of that straw out of the way. So probably the biggest issue with ours is getting that fine chaff, especially off things like barley, and getting that spread evenly, and then also being broken down enough to get through. So this year we're having to play with some residue managers. So we're going to selectively put a few on. It's something we really don't want to do because, like Tim said, it's just a lot of moving parts, more things to repair, more things to monitor when you're going on. So we're kind of against them a bit, but I haven't quite answered that, but that's pretty close. Yeah.
Thanks. And we'll just take the questions as they're coming on the screen here. And I'm quite happy if people put their hand up and ask questions while we're just going through that. But Tim McClellan, did you ever consider buying a disc machine? If so, or why didn't you buy one?
I didn't give it too much thought. I think for our system, where with herbicide incorporation, maintenance on discs, the inability to sow in certain conditions, either too wet or was something that probably swayed me against it. Whether they're real or not, that was sort of the view that I'd sort of read and heard through discussion. So it wasn't really in our decision set, the disc machine.
So, yeah, John, probably on that too, you mentioned the wet. That's the Achilles heel of a good disc system is when it's sticky. And down the Wimmera, we've got a lot more stickier soils and some of these nice sandy loams. The sandy loam generally can get through anything, that's fine. But I guess the whole reason we shifted to a disc in the first place is so we could sow dry. So we really should have like 2/3 of our farm done by that time we get that first big rain. So we should be trying to get through it. So hopefully that's fine. But last year it rained on the 1st of April, which was the first day of seeding. So it did cause some issues later on after 90 odd mil in April, or what did we have? We had quite a wet April.
So if we could just move on to spend a little time on seed and fertiliser placement. I mean, one of the issues that we know is that getting nitrogen and phosphorus in the right place when we're sowing, and not too much N, but enough to get us going, because that is a big limiting factor, nitrogen. Tim, how do you get on putting nitrogen down in your system? Tim, I'll go Tim Reethers, sorry. Tim A and Tim B, or Tim 1 and Tim 2.
No, that's right. Our fertiliser program, we've got our philosophy is one type of granular fertiliser. So we run a P and we can just get truckloads of that and put in the silo. It's the same for the legumes, it's the same for the wheat. We just adjust the rate. And then we actually have a liquid system on our seeder, so we can actually dose it with UAN if we want. And so we're spraying that on the furrow walls as we go along. So we can get targeted. Obviously, we're not going to get 100 kilos of N out. We usually do up to 40 litres, which is not far off for about half that, so it's about 18 units or something of N. That's about all we're going to get out. But then we're also attacking the N pretty early once it comes up. So we'll be coming out with a spreader because it's wet in winter and spreading out granular, which is cheaper.
Tim McClellan?
Yes, so we've got a triple bin on the back. So we have seed, a phosphorus fertiliser and a urea fertiliser in the 3 bins. So we have 2 centimetre separation, which is adjustable with our point, so we could make it 4 centimetres or 6 centimetres if we want to, but 2 centimetres is the happy medium that we're running with at the moment. So the phosphorus goes with the seed based on a DGT phosphorus test to guide our rates with the seed. And then for nitrogen, last year we did depending on the soil test results, they either got 20 kilograms of nitrogen or 40 kilograms of nitrogen. Last year, while I was sitting on the seeder and I was having a bit of a play around, I just kept on bumping up the urea rate to see whether I could burn the crop off as I was driving along. Admittedly, it was amazing conditions last year with rainfall. We had 100 mils in April, which if you're going to get conditions that will stop you from getting seed burn from fertiliser, that's it. But however, I ended up blocking up the seeder because I put it up too high. But I didn't see any response to seed burn from nitrogen.
Yes.
So I think based on that, we're going to try and maybe put a little bit more up front than we might have in the past.
That's interesting too, because Dad's always been a firm believer. I can remember a paddock on the highway that he, when we were pre-drilling with the Flexicoil, and he cooked it and it would look magnificent and then just didn't yield. But since that's happened, we've been doing enriched strips where we'd put double the rate out in spread, and we just can't seem to burn it, and it always seems to yield more. So I think that backs up what James Hunt's saying, where we're just not putting out enough. So yeah, we're kind of much more gung-ho in it now, knowing that maybe it's the change in farming practices that's let us do that, and we sort of progressed down the path a bit further with our conservation farming practices, and I think that's allowing us a bit more flexibility.
A little bit in the same vein, following on from our earlier presentations this morning, really talking about herbicide residual and avoiding herbicide damage to the crop. Well, Tim Reethers, we'll continue on with you, Tim. How do you go with the herbicide and your machine?
Yeah, it's got benefits and negatives. Obviously, pinning's a problem. So because pinning could have stubble around the seed, we apply all our pre-emergence after we've sown, because we don't clear the furrow anyway. So there's certain products we can't use. We can't use Treflan because we don't have any soil throw. So we've got a selection that we're comfortable with, and we apply them after, which is great because it gives us flexibility about what timing we can do it. We can do it just before a rain event. So if we dry sow and it doesn't rain for 3 weeks, our Secura is not wasted, which is really good. But that also stops any residue getting down the slot, chemical residue getting into the slot when we're actually sowing the seed if we did pin. So we just got to be really careful with that. And the other thing that's a problem is if you've got a lot of residue on the stubble and you did pin it, you can't avoid that. So like a lot of Group B on the stubble, jammed in the slot with the seed, you've done your best to put your new pre-em out clean over the top, But yeah, we can still get some ring barking and stuff happening. So we just have to use zinc and things like that to supercharge it and try and get it to grow through it.
Tim McClellan, I guess speed's one issue with your machine?
Yeah, knife point press wheels. So we're sowing around 10 k's an hour. So 2 years into it, season one, we set to just try experimenting with sowing depths with the new seeder. I think that in our first year, we were probably had a bit too much soil throw and a bit too much seed protection. So we were moving too much soil away. And we ended up with very good weed control in the inter-row, but in a lot of weeds coming up in the crop row. So either we'll slow down, last year I also toyed with lifting up the sowing depth a little bit so that we'd have less soil throw. And that worked fine in the majority of paddocks. It's just there was a couple of our pasture paddocks that were quite hard set, so we didn't quite get the breakaway of the soil that we required. So we had some germination issues of the seed not being sown quite deep enough. So we're still learning with the new seeder to get the right sowing speeds and right sowing depths so that we can make the use of the herbicides that we're applying out there a bit better. And look, maybe we'll start to consider some post-sowing pre-emergent applications to get more control in the crop row so that we can keep the speeds up and do it that way.
Yeah, I think it ties in quite nicely with the first presentation we saw today, where they were talking about how the activity of the preem is affecting the seed and making sure the row's clear. And I think we've just got to look at making sure those rows are closed. See, most of those examples we saw this morning were due to the furrow not closed, your press wheels haven't done a good job, and then you go and spray something over the top and you're almost directly contacting the seed. It's got far less soil cover than you think it do. So for us, the key thing is to make sure that slot's closed at the correct depth. Maybe you have to go deeper to make sure that happens. So yeah, we're really careful with that sort of thing.
Tim Reethers, you also say you have issues with, pests. We talk about snails, mice, slugs, insects are a big issue in your crop establishment. What does your seeder have to do anything with any of those other issues that you've got to deal with as well?
Yeah, we got a PJ green on the seeder, so we can mouse bait on the fly. So that's really, really good because it saves a whole extra job. You just load up with mouse bait, a couple of drums will last you all day quite easily, and then it's just got scatter plates across the back of the bar, so the distribution's really good. Just takes a siphon. Actually, we've put a separate fan on, which we had to use just on that, but you can just take a siphon out of your existing plenum. And then you just got to monitor it. So before the season starts, I go out and I check mouse numbers, as we're told to do, and look at snail numbers. Snails are a bit harder to deal with, but summer activity, try and hit them in baiting in March, as we're told to do. And the insects, generally, we've got to get a good insecticide package on it. So like imidacloprid on most of our seeds. It's just such a good investment, and it's safety. If we're up against some sheep farmer, you'd need it because of all of the wogs that come out of their place. And they're not just sheep, yeah.
Tim McClellan, you probably haven't got quite as many issues as Tim Reethers got down south there, but...
not too many. No snails. We put imidacloprid on our seed as well, and I read a tweet the other day that if we think back to 2011 with the last locust plague that came through, there's apparently a few locusts that bought that imidacloprid will... It has activity on the locusts, and there was less effect on it, which I thought was pretty interesting. So I'm glad we've treated our seed this year.
Tim McClellan, just staying with you, are there any different sort of crops like canola or wheat or barley or lentils give you any particular challenges setting up your sowing machine to make sure you get optimum germination?
I don't think so. Like the seeders, it doesn't have a small seed box, but the metering system in the horse works very well. We have different rollers for different crop types, and in 2 years we haven't had any major issues apart from that depth one in the wheat that I spoke about before. It's a nice system, works very well. I'm very happy with it, and hopefully it'll last a long time, John.
Jim Reethers, any difference with crop types?
Yeah, I guess the same rollers change. We've just got a John Deere air cart. We can have issues with oats. The fluff off the oats can sometimes jam the flaps on the section control, which is really annoying. Leaves a nice 10-foot strip for a little bit until it sorts itself out. Probably the worst one is just getting the canola right, because we see I do the counts after they've come up, and you just see that your canola germination numbers are so poor, and it's either something ate them or they didn't come up or you didn't place them when you got chemical damage. And so I think that part of that is we just have to pay more attention to it. I think in some of our loose black ground, our closing wheels, we've got a paired closing wheel system, squeezing from both sides at the same time. And when they do it, I think if we sow shallow to catch that first rain, I'm talking 10, 15 mil depth we're aiming for with our canola. I think at times maybe we squeeze the seed back up. We're actually not doing as good a job as we thought. So on one end of the paddock, you checked it and it looked fantastic, but the other end wasn't so good. So I think we can get a bit patchy results. And every machine's a learning machine. And as we saw from the BCG trial last 2 years ago, I should say, that the ones that were the oldest were often the ones that were set up the best. So I think we're still on that curve of learning.
So, Tim Reith, this is your chance to give some advice to everyone out there that's thinking about buying a new seeder. What sort of the key things you would look for if today, I think you said a seed lasts about 15 years, but let's say you have to have a new seeder by next cropping, what would be the 3 or 4 key things you would look at in a machine?
I'd say probably the key mistake I think people make is they look at what the neighbours have got and think it's doing a great job, but then they try and force that seeder into their system and they don't necessarily make allowances for it might behave differently. So, if you're going to a disc seeder, there's certain things you just can't do anymore. And so you've got to be prepared to change other parts of your management system to deal with that. And that could be a benefit, it could be stress, and you might be just easier sticking with what you got. But I think the key thing is to make sure you know where you want to go. The seeder is just one part of the tool of growing your crop. It's not the be-all and the end-all, so it needs to fit in with everybody else.
Tim McClellan, we look over the fence at our neighbours to see what they're doing. Some advice for the neighbours.
If you're buying a seeder, John, I just spoke to as many people I could who had the different seeders that were in our decision set. So I talked to them and talked about the pros and cons of them. And the guys that I spoke to around Horsch, it was a relatively new machine in Australia at the time. But when I spoke to people, they loved it and it was a great way to go. So. Did that help, Dad? I don't know. Yes, it did help.
So a question that we have here at the moment is, I'm not too sure who would like to start to answer this one, but what's the return on investment been like on the new seeder? Have productivity and accuracy gains paid off with the machine?
They're
both keen here.
Yeah, I'm happy to start on that one, John. It was a big investment for our farm business, so I wrote a business case to present to the family to say this is why we need it. And I can't remember the numbers now, it was about 4 years ago that I did it, but it was very clear that we were going to get a return from going from our old seeder to our new one through better germination and better crop, and also in terms of efficiency, in terms of getting it in the ground on time and as well. So I probably should go back and review those numbers and see whether they're any close to the mark, John, maybe.
Is it difficult training it to staff, Tim, bringing a new machine like that with all that technology on it onto the farm? You've got a good training program, I suspect.
Tim Reith is suggesting, is he talking about Dad? But so one of the issues with the Horsch is that they do have quite a small screen, and our workman has trouble deciphering the buttons. As long as I'm up to speed with it and know what's going on, then I can usually convey the information to Richard, our driver, to get it working. It does rely on me having to set it up when we move into new crops and do all the calibrations and that sort of thing. But we've trained up Julie, my wife, to know how to do all of that stuff as well. So if I'm indisposed or can't get there, then she can come out and assist as well. So yes, there are some issues with technology and older drivers, but we've worked out systems to make it work.
Tim Reith, is the return on investment?
I think the alternative was that we were losing out on establishment. So I know a researcher must have written that because they asked about return on investment on something that was really hard to measure. But going wider, you talked about labour. With ours, probably Luke, my brother, he's 70% seeder driver, and our other farm hand's particularly good at attention to detail, so he does the other 30%. So we've got 2 good drivers, and it was better to run one massive machine and utilise that driver pairing rather than trying to go for 2 smaller machines and potentially have more cock-ups. So I think it's paid for that. Another thing that's massive on our farm is reliability. So our machine can do up to 30 hectares an hour. We can get across it, and if we have to keep fixing the thing, which is what old machines do, they just fatigue and start breaking. You just got too much downtime. So we just hate downtime. You got to get things done at the right time at seeding. It's critical, and it's one of the worst times to lose time. The other end's at harvest, and the other time's at spraying.
Thanks, Tim. And Tim, we've just got time for 1, maybe or 2 questions. If I push it, Fiona, yes. Are there 1 or 2 questions or comments? I think Tim and Tim would be happy to take comments as well.
Comments?
No? Well, Yes, John.
Did you change from to Tim? Tim left. Where I'm sitting. That's your left or mine?
With the wheat, do you mean what? Or? Yeah, so the way that the horse system is, it's the press wheel determines the depth. So you adjust it from +1, sorry, -1, -2, etc. So I had it on -1, but because I was trying to reduce the amount of soil movement. So because it was hard, it didn't penetrate as well. So I then just went down a notch, and that was enough to get it into the ground a bit better.
Thank you. I'd like to thank Tim Reithus and Tim McClellan for their input and their open and honesty, so please show your appreciation to the two Tims.
Thanks, John, and thanks, Tim and Tim. We now move on to our high-performing soils session, and it's my pleasure to welcome Michael Moody from Frontier Farming Systems to talk to us about some of the work that he's been doing across the Wimmera Mallee. And he'll be followed, just in case I miss this, by Kate Madden. So thanks, Michael.
Yep. So sorry, this talk's going to be more Mallee and less Wimmera, but that's where we're at. So thanks everyone for having me here today. So we're going to talk about, I guess, the stuff we're starting to get quite a few results coming around our deep ripping work that really only started 4 or 5 years ago through a GRDC funded project looking to improve productivity on the deep sandy soils in the region. So the context of this is really targeted at the deep sandy soils, and because of the scope of the project, haven't really done a lot of work looking out into other soil types. So just bear that in mind when you're looking at the results. So what we're really addressing is this basically a physical constraint in the soil, where we're finding these bulges of resistance occurring. Once you're getting past about 2,000 or 2 MPa, that's the critical limit where root growth will be restricted. And so we're finding that a lot of these sandy soils that we're working on are having these profiles where we're getting a bulge anywhere from about 30 centimetres to about 60 centimetres down in the profile. So we're doing some work, or the project's doing some work through CSIRO to look at what might be the mechanisms that's causing this resistance. I personally don't believe it's all just due to machinery compaction, but at the end of the day, it seems to be by reducing the penetration resistance, targeting this bulge, bringing the resistance down. That's where we're seeing some really great responses in terms of crop growth. So we're starting to accumulate quite a lot of soil types, or trial sites now. This is just from the Sandy Soils project. And you can see here, this is the first year responses. So the first year crop response after we've deep ripped. And you can see here we've got a 1-to-1 line, and you can see that the majority of the points there are above this 1-to-1 line. So that means that we're getting a response in grain yield above what you would have done without ripping, and that's occurring the majority of the time. And so those first year responses on average are about 0.6 of a tonne per hectare. But the range that we've seen is anywhere from 0.2 to as high as 1.6 on these sites. We're starting to build up a little bit of data for more long term, but we're seeing those benefits flow on as well. And again, that range of 0.2 to 1.2 tonnes per hectare in subsequent years is being observed on these soil types as well. So you're not just getting that first year effect, we're starting to see a longer term benefit on those soils, which, given it's a reasonably costly practice to do, we need to see those longer term benefits. And the one site that we have got that gives us some hints into the longer term benefits is our site that we started in 2017 at Oyen. So in that trial, we had a treatment where the ripping was conducted every year, and we also had another treatment where it was only a once-off rip. So you can see on your left there, where we've ripped every year, our benefit over that 4 years now has been 2.6 tonne per hectare. But where we ripped only once off, that benefit is still been quite significant, cumulative over that time of 1.8 tonne per hectare. So you can see that the once-off rip is also tailing off. So that's going to give us some idea of what the time frame might be to when we'd expect that ripping benefit might sort of subside. So we're sort of thinking gut feel, maybe 4, 5, 6 years benefit to rely on. The other trial at this OUN site is also looking at spading, and there we've put different organic matter treatments out. That also commenced in 2017. And you can see that the organic matter treatments at this site have given us where we've applied chicken litter, 3.3 tonne per hectare benefit over the 4-year period. So that's 3.3 tonne per hectare more than what the unspaded control would be. So that's the additional amount of grain grown due to that treatment. But you can see still within that 3.3 tonne, 1.3 tonne per hectare of that is due to the spading. So the spading is also loosening that soil profile. So by spading and putting no extra amendment out, we're still getting 1.3 tonne per hectare benefit. So I guess when you're tossing up ripping or something else, spading is a real option if you've, say, got non-wetting soils that you need to address at the same time. That may be a better option than just ripping on its own. Perhaps you've got some sort of acid throttle layer there that could be addressed by incorporating and mixing that soil a bit more. So understanding the soil profile, understanding the constraints is really critical to how you go about addressing those constraints. One of the interesting findings from that those OUN trials is we're starting to get a bit more understanding about what's driving the yield responses. I guess being a bit naive at the start of this work, I would have thought that a lot of the yield response on these sandy soils is coming from being able to tap deeper into soil, use up moisture that may have not been used up previously, and then you'd need a recharge of that soil to continue to get the benefit. What we're actually finding is these ripped soils are actually not actually all that different in terms of how much overall water that is being used. But what we're finding is we're shifting the balance from losing that water through bare soil evaporation, so rainfall that's landing and then just being lost before going through the plant, and we're getting far more evaporation, so productive water use in there. So that's a really great finding because that means that we're going to more likely see that benefit as an ongoing outcome rather than having to worry about the water balance and just getting a ripping effect when there's extra water available. One of the exciting areas is what we've seen in terms of responses on legume crops. This was a picture I took at Coolanong last year. Legumes in the mallee environment have really been hampered by what can be produced on the deep sandy soils. And here we've seen some great responses to the majority of crops, legume crops, to deep ripping and really lifting production up in terms, sometimes doubling or even tripling production. So we've managed to run about 5 different trial sites in combination with Jason Brand over the last couple of years looking at this. And again, this 1-to-1 line is showing this really great benefit of ripping and the response in the crop, pulse crop. So that's something that's really going to transform the dynamics of growing pulse crops in this environment. The one thing I would notice though is, that's a bit interesting. These little open circles here are lupins. So interestingly, lupins that are pretty well adapted to these soil types already aren't actually responding to the ripping as much as the other crop options there. So where we're seeing doubling of yield in chickpeas, lentils, field peas, Other crops, lupins, we're seeing about maybe a 15 to 20% yield advantage. And even last year we had one site where it was actually a disadvantage because of the shallow sowing of the soil, of the requirement of the lupins, very poor establishment and rip conditions, and actually saw a negative advantage. So if you're going to rip and look at legumes, then I'd be trying to stay clear of lupins in that environment. And this is a question we've been getting asked a lot, and this is just some data. I've only just pulled this together yesterday, so I haven't had a lot of time on it. We're just asking what soil types in the paddock are responding, and where in the paddock should we start and where in the paddock should we stop. So this is a paddock that we run in the South Australian Mallee, where we rip from one end of the paddock to the other, 2 strips with some control areas in between. So we're able to try and look at the soil variability there. And so the top 2 lines, the orange line is one end of the paddock to the other with the rip treatment. The blue line is the unripped control. So you can see that it's not an overall benefit from one end of the paddock to the other. But down below you'll see a bit of a yellow line there. That's an EM map or an EM value going up from one end of the paddock. So you'll tend to see that the lighter soils or the lower EM soils where we are picking up the majority of the benefit. When we're getting into the more heavier soils, we're starting to see a not so much of a benefit, and in some cases even a bit of a negative yield there. So yield maps are very noisy when you pull them apart, but you can see on the right hand side there a regression or some data which is EM38 graphed against the yield benefit, and it's starting to tell a story that targeting the ripping to these sandy soils is where the benefits are coming from. Have you got a time? Yep. So I'll just finish on this slide then. Conscious that I need to allow time for Kate. So we're now trying to move in. So we've pretty well established a pretty good case for ripping these light sandy soils, and we pretty much think the economics are there. But now we're looking about how we're going to do it. So much like the seeder discussion before, that we're trying to learn how we can actually set the ripper up in the best possible way, and do it in the most economical way possible. So this trial last year, we had ripping with our tines set up at either 1/2 metre, 75 centimetres or 1 metre apart. And then we ripped to a depth of 30 centimetres, 45 centimetres or 60 centimetres deep. So our best yield responses came, which was a 1.2 tonne per hectare yield increase. So this is the first year of ripping. When we ripped to at least 45 centimetres, and we had that row spacing at 1/2 metre, we could get the same yield benefit if we pushed our tines out, but we had to be ripping deeper in the profile to do that. So you had to be ripping at 60 centimetres deep at a wider tine spacing. The other thing that we looked at was the addition of a experimental wing, we're calling it. So an attachment that we've put on to try and increase the amount of loosening in the soil profile. And if we'd put that wing on, we could get away with ripping at a wider tine spacing and also at that 45 centimetres depth. So there's a bit of work happening in this space, but the concept is how wide can we push those tines apart to get that yield benefit? Because the wider we can push those tines, and obviously the shallower we can rip, the more efficient it's going to be, the less costly it's going to be. And looking at those wings looks like a great attachment to try and help that out. So leave it at that.
My notes. Sorry, I'll just flick. It's a pity we didn't get to touch on those slides because they've got some really useful things on them. So where Michael talked about sandy soils primarily in the north, in the Mallee, I'll be heading back home to the Wimmera, heading south. where we're not quite as fortunate to have the deep sands that the mallee's got, which are quite responsive to ripping, and instead looking at some different soil types. I will just quickly mention that there's a couple of other treatments that I haven't got time to talk about today. Clay spreading is one, and balanced fertiliser rates to the amount of manure we're putting out. So I would really recommend that you go to these articles and have a look. And I do just quickly need to mention that this project was supported by the Wimmera CMA with funding from the National Landcare Program. So I'll quickly run through, we've got 3 different trials across 2 sites. So the first site I'll refer to as our Lubeck site. So it's between Rapanyup and Glenorchy, and as you can see from the soil core there, it's quite a coarse, sandy gravel, and there's no clay throughout this profile. It doesn't get above 10% clay all the way down to a metre. So this soil has a really low water holding capacity. The crop really struggles to access the moisture when it needs it most in a spring. The other trial I'll be talking about is what I'll call the Netherby Site, which is halfway between Rainbow and Nil. One of the key constraints we're facing on this site is a very non-wetting sand. So this is our trial site there, that square. And then you can see where the farmers struggled to establish a crop due to the non-wetting. It also has quite a hard compacted clay subsoil sitting about 20 centimetres. So the first soil amendment we've been looking at is applying manure, so both chicken at Lubeck and duck at Netherby, just what's locally available. And we've seen really strong responses to this across both soil types. So at Lubeck in the first year, we saw a significant yield increase of 1.2 tonnes per hectare. The second year response, so we didn't reapply, this is what's carried over. We've seen a 300 kilo increase per hectare in the chickpeas that we sowed last year. And then at Netherby, so first year here, put out the duck manure and we saw a yield increase of 0.9 tonnes per hectare. So this wasn't really expected because the soil test showed that we had enough nutrients in the soil to grow up the crop that we did. But applying additional nutrients seems to have had a real yield benefit here. And I think it links quite closely with Harm's phosphorus work that he'll talk about later on. The other technique we've been using, similar to Michael, is looking at deep ripping. Because we're on some different soil types, we're not on those deep sands of the mallee. We've had quite a mixed response. So in Netherby, the first year after ripping, we had about 150 kilo per hectare increase in the wheat. Again, really strong ripping responses in the chickpea of about 300 kilos per hectare, which actually managed to cover the cost of deep ripping in the first season. But then no response in the lentils. And at Lubeck, we haven't seen a response to deep ripping at all. And this is because the key constraint of that soil type isn't that there's a hard compacted layer. The key constraint there is that there just isn't the water needed to grow the crop. So stirring it up doesn't actually change that. So why did deep ripping work at Netherby? And I'll quickly run you through this slide. So similar to the ones Michael showed on his first slide, across the top here, we've got penetrometer resistance measured in kilopascals. So that's a measure of soil strength. So you take it with a penetrometer, which is essentially a fancy stick that you just push into the soil, and it gives you a number of how hard it is to push through that soil. So it really closely relates to how hard the roots have to work to grow through that soil. Then down the other side, we've got the depth. So how deep in the soil is the compaction that we're seeing. So from about 1,500, roots will struggle to grow through it, as Michael touched on it. But from about 2,500 onwards, root growth is really severely restricted or not possible at all. So the roots are really having to work quite hard there, and in some places they won't be able to grow through that. So by deep ripping, you'll see, so the orange line is where we've ripped, and the green line is the control where we haven't ripped. What we've essentially done is taken out that compaction layer that's sitting about 15 centimetres, and we've allowed the roots to grow and access more nutrients really easy through to about 30 centimetres. And that can have other differences that lead on from that, including better early vigour because it's able to put its root system down faster. So that's the reason behind why we saw that yield response at Netherby. So if you're in the Wimmera on a different soil type, there's a couple of really important things to consider before you deep rip because, as I've shown, you're not necessarily guaranteed the yield increases that the mallee sands have shown with Michael's work. So the first thing to really strongly consider is compaction or soil hardness your key constraint? If it's not, look to address those constraints first before coming back to the hard compaction layer because you're probably less likely to see a yield response from ripping. So to determine this, get a penetrometer, a stick, a shovel, or hopefully Michael's EM38 work will lead to something in this. And in moist soil, go for a dig and see where your hard pan is actually sitting. Make sure you do it when the soil's damp, because if it's dry, it'll come across hard no matter what. The next thing is, once you've worked out where it is the equipment you've got actually able to rip to that depth? So the farmer we worked with at Netherby, Robinsons, and thanks to them for hosting the trial, they essentially thought that they were ripping a lot deeper than the penetrometer data that showed. So there's a couple of things in terms of downforce and tractor power and tine design. So it's important to make sure you can actually get at that problem layer. And then finally, if you've said, yep, compaction's my number one problem, this is what we're going to work on, I'm going to deep rip, you also need to consider how it'll fit in your system. So the first key thing is seeder setup, and unfortunately Michael didn't get time for his slides, but because you've loosened the soil, seeding depth can be really quite variable, and soil throw can be another issue, so it's important to make sure your seeder is set up correctly when sowing into recently deep ripped soil. It's also, because of that, really important to consider your crop rotation. So what crop types can handle variable seeding depths better than others? So canola versus chickpeas are the two extreme ends, but that's something to consider as what you're sowing that next year. Herbicides can also be a problem. You've loosened your soil, so soil coming back into the furrow can be a problem, and you've also decreased your organic matter, so herbicides can be hotter than you would expect. So that's something else to consider. And finally, nutrition. So with deep ripping, you might have bought up a lot of less nutrient-rich soil, and all your years of phosphorus going out sowing now might be a lot deeper in the profile than you'd expect. Combined with the increased water uses of efficiency, it's really important to make sure that we feed these crops properly. So with deep ripping and soil amelioration, it's not a one-size-fits-all approach, but I would like to stress that these approaches can have real yield benefits on responsive soils. So this is taken from the Netherby site, which was responsive to deep ripping. So by overcoming that physical constraint of the hard compaction layer and then applying additional nutrition, what we ended up seeing was a yield response of about 27% compared to the unripped control. So on responsive soils, this can have real impacts on farming systems and profitability, but it's not a one-size-fits-all approach and it won't work on all soil types. Thank you.
Thanks, Kate. So we've got a couple of questions. Michael, you might have had a chance to read the first one, but it's from Pete from Patchy. Is there a practice within our farming system causing the resistance or compaction issues?
The ripping stuff that I put up there, I think it's more of a natural process within the soil, whereby sort of finer particles are sort of moving down the profile over time. I'm talking, tens of years, decades. So I think that's what we're addressing. So we're getting more of a cementing thing. But that's not to rule out that our other compaction, potential things like trafficking and whatnot might be at play on other soil types in the paddock. So if for example, on your heavier soils, you would see a response to ripping, it may be due to that trafficking and sort of that on other parts of the paddock. So that's my take on it. But I know there's a lot of people that are, moving to ripping while also moving to a controlled traffic system. I don't think that hurts, but I don't think that's the total answer either.
Thanks. And the next one from James Hunt. Are you getting less evaporation from improved crop vigour covering soil faster, or water moving deeper and away from evaporative zone?
I think it's the first one. So the thing that we continuously measure more in terms of from a plant physiology point of view is greatly increased tillering, like heaps and heaps of more tillers. So that's producing a canopy, providing shading. But some of the ripping responses we've seen, particularly at O in the last couple of years, and Carwop and other places, have been these really dry years, 100 mil of rainfall. We think some of the benefit is actually coming from this canopy, the tillerers, and the tillering is actually almost potentially working like a water harvesting effect, like our furrows, if you know what I mean. It's like collecting that little 4 mil rain event out and turning it into a 16 mil rain event in a furrow rather than having a piddly canopy that's just landing there and evaporating off. So I think that's a bit of a hypothesis, I suppose. We can't confirm that, but my observations would be it's about that sort of reduced evaporation from the canopy, but also that canopy acting like a gatherer in these small rainfall events and channeling more water into the root zone.
And the next question is more general. Any soil erosion issues with deep ripping? And then there's actually another question that sort of relates. Oh no, maybe that's disappeared. So soil erosion?
Yeah, so I'll talk about erosion, and there's a question around establishment. I think they go hand in hand there. Yes, there can be definitely soil erosion problems. So there's the obvious ones. One of the things is we've observed is the ripping process doesn't need to destroy ground cover. So if you set your roller up properly, if you've got a crumble roller, if you're ripping into nice sort of, when there's a bit of soil moisture, it should be a pretty non-invasive problem. I think if you're bringing up big clods and big rocks and then you've got to go a second pass and try and belt those down, and that's where the ground cover's being destroyed. The second part of it is the establishment problems has been a big problem, and the trafficability has been a big problem for growers, and what that does is cause these great furrows, and then soil collapses on the germinating crop and buries it at 10 centimetres rather than 3 centimetres. So the critical thing, there's a few things farmers are trying there. We've done a trial which I was going to talk about, but I ran out of time, on last year looking at rolling. Going back over with a steel drum roller really helps to actually, I call it consolidating that seed bed again. And remember, because we don't think we're dealing with compaction in the top, 10 or 20 centimetres, it's deeper in the profile. That rolling, I don't think, is having an overall negative or reversal effect in that case on these sandy soils. So going back through with a steel drum roller, trying to reconsolidate that surface and allow the machine to traffic and get your seeding depth right is critical to preventing that erosion effect occurring.
I'll just jump. Oh, sorry, Kate, do you want to make a comment?
Yeah, I'll just quickly touch on establishment. I think this is also where timing of operations is really critical. So we got slammed, sowed at Lubeck onto some ground that our trial had been deep ripped there, sowed and then got 35 mil in the 3 days afterwards. So I think if we had only had 5 mil and nice gentle rain, we would have been fine. But because it got so wet, the soil was quite loose. And seeding depth was a problem, but herbicide injury was nearly as big an issue. So I think it's one of those things that maybe if you were considering sowing your deep ripped paddocks, you'd look at that weather forecast pretty closely, especially if you hadn't rolled it, like Michael was saying.
So in the Mallee, wind's been our biggest challenge. So having that, almost the worst case scenario is that the seed actually germinates and then the furrow collapses on top. What we've actually found is a lot of the damage is actually being done by the front tine. So if you've got a parallelogram set up, your press wheel's controlling the seeding tine, but the front tine hasn't got any flex in the system against changes in flotation on your bar. So you actually find that front tine is either scalloping the soil too deep or throwing over onto neighbouring rows and stuff like that. So actually looking at your machine, and if you're worried, if you're able to lift that front tine up, will actually help a lot in trying to minimise how much, how far that's working into the soil and then lifting soil and causing soil throw and other issues.
A few more questions. So at the top, is the difference between Wimmera versus Mallee going to be less likely in southern areas when fronts come across and subsoil moisture is less important?
I don't know, I'd say subsoil moisture is pretty important no matter where you are, and sometimes the Wimmera gets itself caught in the springs. I would say probably less likely because, getting that roots down, if your top 30 centimetres is moist all the time, well, then your crop could be quite happy there. I'd say the other reason behind me saying it's less likely to have such good results in the Wimmera is just purely that I think the Wimmera is a lot more likely to have a lot more other constraints. We see soil pH come in down there, we see toxicities and carbonates and other soil factors come in the Wimmera. I'd say, sands generally are a sand. They can have other issues, but generally, I'm expecting that it'll be a lot less. You could still get good responses in the Wimmera, but not on all Wimmera soil types.
This is coming back to soil cover again. Maintaining cover if sowing pulses after deep ripping. Are you better to sow chickpeas the second year after ripping?
So it's an interesting question that we're thinking about a lot. So I wanted to sort of point right at the start that we're really only 4 years into looking at this. So some of these more complex system things are really evolving, and really it's going to be, seeing more farmers uptake and solve these problems will be probably what's required as well. But there's an interesting angle. You'd think the first angle is yes, because we've got to look at systems of a way of maintaining that ground cover and then improving that because we know that the chickpeas and lentils and legume stubbles are very vulnerable. But we also know we get the biggest bang for our buck in the first year after ripping. It seems to be a bit of a declining thing over time because it's not permanent. So there's another interesting angle that you could take there is how do you actually maximise profit from the ripping process in the first year. So, if you're getting a 1 tonne per hectare benefit on cereals that are worth $250 a tonne, as opposed to a $600 per tonne benefit on a chickpea that's also giving a 1 tonne benefit, then there's some of the more complex questions that need a lot more analysis. I can't sit here and answer that right now, but that's some of the thinking that I think goes behind that. The other risk also from erosion and bare soil, and Kate touched on before, is obviously the risk of herbicide damage. And you would have thought that would have been a really high risk situation that we already know Group Cs on our pulses can be very hot and can do a lot of damage. Interestingly, I reckon our observations from trials, without having full quantification yet, would actually be it's probably the reverse, is that even though you've probably got more herbicide moving into the row, I believe I've seen less damage, and I think that is due to, we know that the Group Cs are going to come up through the root system. So my theory is there that the roots are growing out faster and quicker away from the Group Cs. So even though we're in a higher risk situation in our legume crops with the chemicals, maybe it's actually the rooting zone is more able to deal with it because of faster root growth.
I'm sorry, I'm conscious of time. I'll just move on, and then Michael, if you had a farm at Birchip with some pretty severe subsoil constraints, this has come from Tim, so I'm assuming that's you, McClelland, would you even consider giving deep ripping a try?
I would, Tim. I'll give you a lend of my penetrometer. Because I think it's about characterising that issue, and if there's no real evidence there that penetration resistance isn't an issue, I can't recommend anyone to go out and try and deal with it. But what's that? Sorry. Well, I'll use my penetrometer and find out the same thing then. So no, not knowing your soil types, but if there's no evidence that penetration resistance is a problem, I wouldn't be starting ripping. But I can say how we got on to ripping in the Mallee, there was a real resistance from farmers to even contemplate ripping before our project started. And how we actually come across ripping being the benefit was actually we're trying to put nutrients in the subsoil. So we actually found that our hypothesis was, these soils get very dry in spring. If we can get the nutrients down deeper, can we actually, keep them kicking along in springtime? But we actually found that it didn't matter where you put the nutrients. It was all down to that sort of physical effect. So if you've got other constraints down there that might be addressed, and I know there's probably lots more people more qualified than me, like, you know, there's lots of people looking at clay subsoils and stuff like that. If gypsum and other things are, and manures are showing an advantage, then, you know, ripping is just part of the system.
And there's another question, ripping on an angle or not?
That was another thing that people are trying and having some success with, and it's more around that flotation of the machinery. So yeah, there are people having some success in trying to keep that seed bed and seeding system working well by going on an angle. So I think that's a good idea where practical.
Yep, Locke, up to that.
Yeah, just carrying on. Do you find there's a difference whether the soil is wet and dry? I mean, that obviously varies with mallee sands, but, you know, trying to break up hard pans, I've heard some people say it's best to be dry so that the hard pan shatters, but what's your experience?
From my experience is that all those results I've put up there today are from pretty ripping when the soil is reasonably moist. So a lot of our ripping's been done, you know, within a few weeks of seeding and stuff like that. So that's my my take on that. We did have some trial data from this year that sort of suggested there was an advantage sowing dry, but there was also some other agronomic issues at that site that were at play. So you know, some summer weed control, you know, extra germinations because of ripping and stuff like that. So until I do more work on that, I don't think my response is, yeah, it's I think overall the benefit of trying to rip when there's a bit of moisture in the soil is going to be better in the long run.
Yeah, I haven't done work on it either, so I'm hesitant in this answer. But work out WA is showing that it's sort of a Goldilocks effect, especially if you've got a clay subsoil. So too wet, it's too soft, your tine just slices through, sort of smudges your edges, most of the middle bit won't have changed and you'll just sort of have made these slots. Too dry, massive diesel bill, massive wear on your machinery, brings it up quite cloddy, and probably you have to work a lot harder to get it as deep as you need. That being said, that hasn't been tested over here, so.
Great. Good-o. Thank you, Michael. Thank you, Kate. It's definitely a hot topic and one that's created a lot of discussion. So we look forward to more research results helping us, you know, decide whether it's something that's fit for our farming system or not. So thank you very much, Michael and Kate. Okay, thank you. Next up, Harm van Rees. Harm is talking about some work that he's been doing in relation to phosphorus across the Mallee and Wimmera and looking at phosphorus responses. Thanks, Harm.
Thanks, Fiona. It's really great to be up here again with a bright light shining in my eyes. So today I'm going to talk about a phosphorus study that we did with Cam Taylor, and as you know that Cam used to work at the BCG, and I also heard today that Cam became a dad today of a little boy, so that's nice for Cam. So fertiliser rates has been an issue for a long time, and when I was first consulting back in '93, we always talked about phosphorus rates, and it is still a tricky decision to make, is on how much phosphorus do you actually need to apply. And even though there are some recommendations around in relation to the soil test of DGT and Colwell in relation to what should be the levels, it's still a really difficult issue. We know much more about nitrogen and some of the other nutrition components than we do about phosphorus. So fertilisers make up, you know, around that 20 to 30% of your total input costs. And how do you actually decide on a reasonable P rate and a reasonable N rate? Now, N rate, I think, with the work that James is doing and speaking after this, we've got probably a really good solution for that, but with soil testing for P is still difficult. So what we tried to do this year is we had 2 sites where we had a fully replicated trial sown with farm machinery. Now, in the past, we always used little trial trials machinery, like what the BCG do in replicated trials. But with all the new gear on board of the current seeders, you can actually do your own replicated trials. And that, I think, is going to revolutionise a lot of the trial work that the BCG can do, but farmers can do themselves as well, because it's a much more robust way of undertaking a trial than just putting in strip trials. So part of this project, we also put in strip trials, and at the moment I'm really struggling with them to interpret them. We have got about 200 of these strip trials in South Australia and in Victoria, and about 40% show an increase in yield, 30% show a decrease in yield, and 30% show nothing. And I think that's the problem, is that when we've got strip trials to actually do the statistical analysis, is nowhere near as robust as doing a fully replicated trial. So Cam Taylor did most of the work, and because of COVID, he actually did the soil sampling, he did the sowing, and he did the harvesting, and all I did was sit at home and do the analysis. So unfortunately, Cam is not here, but he did all the work. Now, Sean Mason is also part of this project, and Sean works for Agronomy Solutions in South Australia together with APAL. So when you look at why would we do small-scale plot trials as opposed to using farm machinery, so the small scale has been terrific for groups like the BCG, the Department of Ag and everyone else, because you can do lots and lots of little trials, you can replicate them, you can work out what the benefits are, and most importantly, what is the process of why something actually happens. And if you know why something happens, you can actually find a solution for it. Now, the negatives on the left-hand side of doing small-scale plots is because it's not your soil type, it's not your paddock, it is somebody else's paddock. And we can make corresponding adjustments to what may happen in your place as opposed to the trial site, but it's never going to be your own farm. And not what we always find in a plot trial is directly attributable on a paddock scale. So when you're doing large scale, it is your paddock, you've got the direct application of what actually happens in terms of the soil type you're farming on, and also on, very importantly, what is the soil P status in this case in your paddocks. And so you've got much more confidence, and now we've got the ability to actually do the stats as well. But it is quite a bit of extra work on behalf of the person doing the actual trial. Now, how do we usually make a decision in relation to how much phosphorus we are doing? Now, most farmers doing a global P test, a DGT test, as well as the PBI, which is the phosphorus buffer index, and your agronomist gives you an equation that supposedly works out what the rate is you should be using. Now, you should question where that equation comes from, because it's not that easy, and there's not a lot of data around to actually test the results of that, to test the corresponding yield increase that you're supposed to be getting. Now, one quick thing you could do is work out over a 5-year, or if you've got longer terms of data, what the yields were, first of all, what you grew, what the yields were, and how much P was applied, and how much P is removed in the grain, because we know exactly those figures. There's 2.8 kilograms of P per tonne of wheat, as an example, and you can work out your P balance. And you can see on this particular paddock, Cam has been sowing, is it shown there or there? So 6.4 corresponds to 13.1 that he put in, and removed 19, so the balance is -6. And if you work out the balance over the 5 years, if you work out the balance over the 5 years, then there's only a positive of 3.6. So essentially, on this particular paddock, the P status, what he's been putting in, taking out, is about 0. But you don't really know whether there's going to be a P response. Now, that's that's Cam sowing the trial, and that is the design that we came up with. So we had the farm rate was 17.5 units of P, a half farm rate, double the farm rate, and 0P, and replicated 3 times, and each individual strip was 100 metres long, and you had 3 seeder widths in each block. So that's a fully replicated trial, 3 reps. Sometimes we prefer 4 reps because it's more robust, but Cam, since he was doing all the soil sampling as well, decided 3 reps was more than enough. So the Caldwell P status for the first rep was 31, DGT was 33, and PBI, that's the phosphorus buffer index, was 105. And based on the current equation in terms of recommendations for response to P fertilizer, Caldwell is quite high, so the test comes back that you have to put 0 amount on to expect you don't expect a yield increase. But for DGT, there was 17 units of P was recommended from that equation. And you can see that on average, the readings are that a reasonable amount of P should be put out in this paddock in relation to both the Caldwell as the DGT P test, and somewhere a little bit more than what he was actually putting on himself. Now, in terms of the soil nitrogen status down to 100 metres, the paddock had average of the 3 zones of 62 kilograms, so not a great deal. So the results of the replicated trial is that the 0P yielded 5.4, and just take note of that letter, and if that letter is different, so for example it's here, it's B, is significantly difference between the 0 rate and the 5.7, and then the farm rate yielded 5.8, and double the farm rate yielded 6.1. So there was a significant increase in relation to the application of P. And if we did analyse that data in the strip trial, it would show you that there was no significant difference between the actual plots. So it's only because of the replication that it actually picks up that there is a difference in doing it. Now, when I do a partial gross margin, then that's just purely looking at the income in relation to yield and the cost of the fertiliser. You can see that there is a benefit. Now, obviously, the benefit between 17.5, the farm rate of P, and 35 kilograms of P is relatively small. It's only $22 per hectare. But if you multiply that out over the whole farm, assuming that it would get similar responses, then that would be a reasonable return for that investment. So Cam is definitely thinking about increasing the P rates in this year and possibly doing more of these tests. Now, if we're having a look at the potential versus the actual yield, so the highest yielding treatment was 6.1 tonne to the hectare, and if I work that out in water use efficiency using Sadras and Angus, including stored water, then you come up with a potential yield of 5.2. So it was a significant increase over what was achieved as opposed to what the equation was. If you're still using French and Schultz, which was developed in the 1970s, and you probably should not be using French and Schultz anymore. Reg unfortunately died about 20 years ago, and he would really like it that you're not using French and Schultz anymore, that you're using a more modern technique. And there are a few others around, and maybe James can raise those too. Using yield profit, and you don't see this very often, the water limited yield and yield profit was 5.7, which means that nitrogen is unlimited when you're running yield profit, and it's only water that's limiting, and the paddock actually yielded 0.4 tonne per hectare better. Now, there's one proviso for that, is that when you put in Scepter as a cultivar in yield profit, then effectively it's the same as mace. There was a 5-year breeding program in the breeding program, mace was developed about 5 years earlier than Scepter. Every year is about an increase of 0.9% in the breeding program for new cultivars, and then it would work out to be pretty accurate. So all the NVT and all the variety trial data you hear, you can actually do it in your head. You just go 0.9% per year and the results are finished and you don't have to listen to 2 hours of breeding program results. Unless there is a disease break or a new disease bred into a particular cultivar, because obviously mace is susceptible to stripe rust, whereas Scepter isn't. So that is a big benefit. So in conclusion, in all agronomic trials we see, there's uncontrolled error. That's part of it. Test plots are never identical, so there's always bias one way or the other. But replication is going to solves a lot of those issues because it allows us to overcome some of that difference between test plots. And large-scale replicated nutrition trials can actually identify nutrition differences. And Tim McClellan did one, and so as well as CAM, and they are doable, they are extra work, but I think the benefits in terms of phosphorus, at least you can start looking at it, can be significant because it's much more accurate than just looking at your soil test result and hoping that there is going to be a response. Thank you.
Okay, this comes from Cranky Pants Fussy Academic Person. Did you balance out the N in the granulock? How do you know you are not seeing an N response?
Because we put on 60 kilograms of N in the crop twice, so we would have overcome that difference. Now, I would love it if we could use triple super or double super, but that's not going to be a realistic response. And when we looked at the NDVI as well as the actual early growth, so at growth stage 30 when we're doing tissue testing, there was a clear difference between the treatments as well. And it wasn't purely an end response that we were picking up in the tissue test, it was also in P.
Simon.
DGT obviously looked like it was pretty reliable. Got that even at 35 kilograms of P. Don't even need to do a replicated trial in that case, would you? Because obviously it told exactly what you found. So would your recommendation be that growers have a lot more confidence in DGT?
Yeah, Simon, I think it depends a lot on the soil type that you're on, because DGT works well in the fairly highly calcareous soil, so we've got free calcium available, and that happens in the Wimmera as well. And the phosphorus buffer index is also a real issue. So you should take that into account, because if the phosphorus buffer index is very high, then that will require you to put more P out, because it basically means that fertiliser P is tied up. So Coalwell P, I think, works really well in the northeast on the more acidic soils, but in the Mallee and the Wimmera, I'm not sure that everyone shares that feeling, but I think DGT is a better reflection, and that's ultimately why it was developed, and Sean was responsible for doing that.
Colin.
With hay making, growing cereals, oil seeds and lentils and that, after phosphorus, would there be any other trace elements that's going to be lacking in our ground?
Yeah, so that's another really good reason for doing both soil testing as well as tissue testing, because if you're doing your tissue testing, then you also pick up what is in the crop at that particular time. And if you're growing a lot of hay, you are pulling out different nutrients than you are with growing grain, and probably at higher level, well, definitely at higher levels. So it is well worth looking at the tissue testing results as well as the grain testing results. So if you do a tissue test, you'll pick up some of those effects if you grow a lot of hay, but also check your grain and get your grain tested for phosphorus, nitrogen and zinc, and possibly for potassium as well.
Question from Jono.
It's 2020 and I have my phone with me all the time and I don't like thinking. Is there an app or an algorithm that I can punch in my DGTP reading into along with my PBI reading and it can just spit out the answer for me?
That'd be nice. I don't know whether we have that. Should we have it?
Yes.
But it is actually on the soil testing. Well, there's a couple of issues there. Most people in the room, if they go at soil testing, and either you do it or your agronomist does it, and they take 6 samples in a paddock. Now, if you've got a really good agro, or you really dedicated yourself, you've got to take 6 samples per production zone in your paddock. Now, that is nowhere near enough. So we did some work a couple of years ago where we took 20 samples in a hectare, and the coefficient of variation, meaning the variability between those results in both cobalt P and DGT and in nitrogen, was huge. And you should be taking as a minimum 12 samples. Now, I hate to say this, and agronomists going out to take the sample rarely do that kind of intensive sampling. But otherwise, you're just going to get variability around the mean, and you don't really, if the actual value is 20, you may be looking at 10 or 30. And how do you know where you are? You're going to put out totally different amount of fertiliser if you've got 10 parts per million as opposed to 30 parts per million. So increasing your soil testing is essential. It's going to cost more, it's going to take more time, but your results are going to be much more accurate.
Just on that, just to add to Jono's question, the DGT actually has that threshold of 50, and it seems to be if anything's to the left of the line, it's very responsive. Anything to the right of the line is basically non-responsive. And BCG did a survey when I was there, and it was very accurate at helping growers make that understanding of soil test decisions. And just to add on the soil sampling side of things, if you are inter-row sowing, targeting your sampling where you're going to put the seed is important too.
Yeah, no, 2 good points. And since you were going to do your postgrad studies on P, it's a pity you never finished it, Simon. So, no, but it's actually quite rare to find more than 50 micrograms per millilitre. So that's the measurement that it comes in. So 50 is actually an unusual high level for DGT.
Yeah, it's more the way it's done, I think, isn't it, Harm? The film that DGT is about sits on the soil solution, and the soil sample you deliver gets fed up to about 80% field capacity, which in correlation to cobalt P is like 1 gram in 100 mils. So it's unnaturally saturating the soil to what field conditions would be like. So you often get fixed phosphorus released into the soil solution, which then cobalt P predicts. And that's why cobalt P often over-exaggerates, and you have to bring in that PBI factor. But we certainly found back then that the DGT really only needed that 1 factor of that 50 to give you a lot of confidence in it. So anyway, just add to that.
Lovely when Simon can actually teach us something.
Wonders never cease.
Thanks, Simon. It's a nice lecture.
There's one more question. Is P removal overstated given there's P in stubble retained systems? P is mobile in stubble.
Well, you're actually removing that P. The stubble, so when I said that table that I showed, that was the amount of P exported out of the paddock in the grain. It's not, we appreciate there's some in the stubble, and when the stubble breaks down, some of that will be available. But those calculations were done with P that has gone out of the paddock. And the only way to put that P back in is to bring it back in fertiliser. Now, it doesn't have to be MAP or whatever. It can also be chicken manure. But if you don't put it back, you're going to run down your P reserves, and then you're not going to grow a lot of crop. Cool.
Okay, great. Thanks, Harm. Continuing on in the nutrition theme, can I invite James Hunt from La Trobe University, who's been working with BCG for quite some time now about novel nitrogen systems. We're now in the 3rd year of some trial work, and yeah, we'll talk about this year's results, James, or last year's results, James.
Thanks very much, Fiona. And before we start, we're going to have a little break to get your minds refocused. And all of those that have got Slido, can you bring it up? Because we're going to ask some audience survey questions to get you all thinking. So grab out your device, log on, and there's going to be 3 questions for you all to answer. So the first question I'd like you all to answer, or those of you who've got your devices, is what percentage of your 2020 wheat crop had ASW protein, so it was less than 10.5% protein? Oh, we get live results. All right, you got the link in the text message if you're wondering how to log on there, if you got the text message. And you can also go to that website and punch in that code and it takes you there pretty quickly. It's quite user-friendly. Okay, we've got more than 2 people replying now, so that's good. 8. Oh. Oh, they're out of order. Okay, got confused there for a second. Okay, so there's a good chunk of people that have very little, so 57%, and then about half, are more than that. Okay, this is the next question, and some people have answered it already by the looks. What percentage of your 2020 crop had APW protein? So that's between 10.5% and 11.5%. So it looks like we're... okay, and then the final one, how do you currently decide how much nitrogen fertiliser to apply? Okay, so we're split between soil tests and an estimate of yield and an educated guess. A few yield profit and soil tests only coming in. Brilliant. Thank you. Okay, I think that's probably got everyone thinking, and I think the thing to really note about this is how many people are making their decision based on gut feel or an educated guess without even any soil testing at all, and the percentage of APW and ASW that gets delivered. It looked roughly from my guess that if you combine those two, it would be well over half. Okay, so keep that in your mind, and if I can ask the AV people to flick to my presentation. I'd just like to quickly acknowledge the co-authors in this work, so particularly Kate and James from the Birchip Cropping Group, as well as my colleagues from La Trobe and CSIRO and HARM, and also thank Paul for giving us a small piece of paddock for hopefully many years to come. Bomber, that is. I shouldn't use his first name, no one knows who he is. And also important to point out that this project was initially funded by La Trobe University and has subsequently been taken up by the Mallee CMA through their, through the federal government's NLP grants. Okay, so the background to all of this is that nitrogen deficiency is still the single biggest reason why we're not growing the crops we could be for the rainfall that we get. So if you look across Australia nationally, and Svi Hockman and Heidi Horan did a study, that was very clearly the case. And if you focus down more locally at paddock scale, and Roger Armstrong led a paddock survey that looked at this, it showed the same thing, that nitrogen supply and availability was really driving water use efficiency and the yield that you could get. And finally, a really strong point of evidence is how much grain you're delivering that's ASW and APW, because if you're getting those grades of grain, then your crop was almost certainly nitrogen limited. And I'll acknowledge that not every grower has a nitrogen deficiency problem. There's lots of growers that don't, but even growers that do a very good job of it often do have a deficiency in higher yielding years. So going back to that survey question at the start, a good way that you can review how your nitrogen management is currently going is by looking at the protein content of your wheat. And this is a pretty robust guide as to how well you've gone with your nitrogen management. So if you're getting ASW, it's almost certainly the yield would have been almost certainly been nitrogen limited. If you're getting a PW, it was probably nitrogen limited. But if you're at AH, then it probably wasn't nitrogen limited. And if you're, well, this is only relevant oh no, it is relevant to Victoria now. You can grow prime hard in Victoria. So that's above 13% protein. Then you've probably cooked it and gone over the top, and you've probably lost a little bit of yield, but you might be making that up in premium price. And those, that sort of rule of thumb is very well backed up by data, and this figure here out of the GRDC nitrogen reference manual just shows the percentages of trials that are responding to nitrogen at different protein levels, and really validates that rule of thumb. So take that away with your thinking about how much ASW and APW you're growing. So why do we still have this yield gap? And to understand that, we need to think about how we're making nitrogen decisions now. And it looks like from that survey, it's largely just a guessing game and an educated guess and gut feel. But if we think about, I suppose, what's considered to be, well, and even people that are making an educated guess are trying to match nitrogen to seasonal yield potential. So trying very much to play the seasons with their inputs. And so typically there's a pre-sowing soil nitrogen test to work out how much nitrate you have in the soil as your first point of supply. Often people will make an assumption about how much nitrogen is mineralising during the season. They'll estimate or try and work out how much yield you're going to get and calculate how much fertiliser you need to make up the deficit between the nitrogen that you have in the soil measured as mineral N versus what you need to get to that potential yield. And by far and away, yield profit, developed by the Birchip Cropping Group, is the most sophisticated tool there is for managing nitrogen to that seasonal potential. So it's kind of the gold standard in that regard. So if we've got these tools and we're doing this, why do we still have a yield gap? And I think the difficulty is that soil testing, as Harm referred to, and using yield profit requires a lot of time and technical expertise in order to get them right, in order to get them performing accurately. And a lot of people, well, most farmers and advisors are really time poor and they don't have the time to put in to get it right. But what I think is probably really the big issue is that even if you're using those systems, it's impossible to predict spring rainfall. And that's not an unreasonable expectation. It's generally impossible to predict the future. Not many people can do it. I don't really know why we expect weather forecasters to be able to do it 3-6 months out. And I don't think that's going to change anytime soon. There's an issue with growers allowing for mineralisation because you're effectively, if you're using that as part of your nitrogen supply, you're running down your soil organic nitrogen, which is pulling down your soil organic matter and your soil organic carbon, because those things are linked. And I think a big part of the reason that people tend to under-apply nitrogen, particularly in good years, is because we fear losses, and the investment in nitrogen is going to go away as ammonia gas or nitrogen gas, and we fear haying off, because I think Tim Reithus alluded to it, that his old man managed to successfully fry a crop that was on the road in the 1990s, and everyone's been very scared of it since. And my parents were exactly the same, like 30 years later, still underdoing nitrogen because of that experience back in the 1990s. So that's a real thing. But all the thinking around nitrogen, I think, has been very short-term focused and finicky for a given season. So what can we change to try and make it better? And how can we change the way we think about nitrogen to do a better job of it? And I think the first point is that we can't predict the future, so why are we trying? It's just futile. We're blindfolded and throwing darts at a dartboard. And generally speaking, in the medium to low rainfall zones, losses are low if you're sensible with how you apply the fertiliser. So why are we so fearful of them? And I've put up an asterisk here because the sort of initial measurements that we'd done in southern New South Wales, we were getting very low losses, less than 10%, but there's some more data that Ash Wallace has published recently in the GRDC updates that shows it can be up to 25 in the Wimmera and Mallee. But in well, certainly in this field trial and where we've measured it, the majority of unused nitrogen is carrying over to next season's crop. So you don't lose it. If the crop doesn't use it this year, it'll be there for next season's crop. It behaves more like phosphorus than perhaps we've really given credit for. As I said, allowing for mineralisation, you're running down your base fertility and the ability of your soil to respond. And I think that with modern agronomy, and I think Tim alluded to this as well, that it's much harder to hay crops off now because of the way our farming systems have changed. So we've got stubble retention, where the stubbles are mobilising a lot of nitrogen during the season. We're growing crops more in rotation with other crops rather than legume-based pastures where you might have had really hot paddocks with lots of mineral N. We're spraying our summer weeds, we're sowing earlier, and our cultivars have been really heavily selected for grain size. If you think back to Meering or Odeon or whatever it was that Tim's dad and my parents hayed their crops off with, they were very prone to producing screenings, but it's really hard to make something like Scepter screen because it's been so heavily selected for grain size. Breeders select for grain size before they select for yield, so it's a strong selection pressure. So trying to put all that together in a package that growers can use to manage nitrogen better, we've come up with the idea of nitrogen banks, where the idea is you're just trying to supply enough nitrogen to achieve water-limited yield in the majority of years. So rather than trying to finically manage nitrogen in every given year to yield potential, you just fertilise up to an amount that will cover you in the majority of years. And there's a few references there that go into it in detail, which we can supply if you want to read them. So how does this work? And we've tried to make it really simple because that's sort of the problem with the previous decision-making tools, is that they're complex. So the first thing is that you need to have an environmentally appropriate nitrogen bank target. So your target is dependent on the potential yield of your environment. So at Birchip, we're finding that about 125 kilograms of nitrogen per hectare is about right, whereas at Horsham, we haven't done the field experiments, but the modelling is telling us that up to or around 175 will be close to the mark. So once you've got your target, you still have to measure your soil mineral nitrogen in autumn, so your soil tests, and you have to do that properly, as Harm discussed. And then all you do is that if your soil mineral nitrogen is below your nitrogen bank target, you just top up with fertiliser N. As per best practice, you can put some at sowing, but probably the majority you're going to put on in July or early August. As per best practice, you top up to that target. So by way of an example, if you measure 70 kilograms per hectare of mineral N in your soil test, and your environmental target is 150 kilograms per hectare, then you apply 80 kilograms per hectare of fertiliser N in order to bring it up to your target. And you just do that year in, year out. So that was the concept, but in order to try and validate and prove it for this region, BCG has set up an experiment. And CSIRO have done some sort of simulation modelling to try and extend that a bit further. So I'll go to the experimental results first. So this is a long-term trial out at Currio at Bomber's Place, and we've got 3 control treatments to compare our other strategies to. We've got our nil fertiliser N, so it's only getting the MAP. We've got a treatment where we replace the grain nitrogen offtake with fertiliser nitrogen. Oh, that's a good question for you. I don't have it in Slido, but quick shout out. What's your biggest source of loss from your farming systems, loss of nitrogen? Grain! Everyone said it. I'm impressed. You are all leading farmers. Yeah, it's in the grain. By far the biggest loss from your system of nitrogen is in grain. So that's what the replacement rate's about. The first strategy we're looking at is our nitrogen banks, and we've got 3 different target levels. Around that level we thought would be about right, so 100, 125 and 150. And then we've got our gold standard, our benchmark of yield profit, but we're looking at it at different probabilities because that's like yield profit gives you a range of probabilities, but at the end of the day, you still need to make a decision about what you think the future is going to hold in order to be able to turn that into a management decision. So we measure soil mineral N. When I say we, I mean the trials team at BCG measure that in autumn, and then we top dress in winter. So some of these results have been presented in past updates by Kate and others, so I'll skim through them reasonably fast. But 2018, if you remember, was very dry, and the nitrogen went out in August. So it was a wheat crop sown after a lentil crop. N went out in August, and it did hardly rain at all for the remainder of the season. So only 8 mils of rain for the month and a half after the nitrogen was applied, and the crop didn't touch it. So the fertiliser went on the soil and it didn't go into the plant. There was no grain yield response and there was no protein response. But interestingly, even though we had a big dump of summer rain around Christmas that year, most of that nitrogen was still there and could be measured as mineral nitrogen in the next season. So this is the relationship between the applied fertiliser in 2018 versus mineral nitrogen measured in 2019. And for every kilo of fertiliser that was put on, we're getting 0.58 of it back in mineral N. We don't know what happened to the rest. Some would have been immobilised, some would have been lost, but we don't know how much. 2019 was a better year, and there was a lot of stored soil moisture, and nitrogen deficiency really showed up in the canola crop. And we got big responses to nitrogen. So nitrogen strategy could double yields. We went from our nil treatment down at 1.2 tonnes per hectare up to 2.4, 2.5 with our more robust treatments. But the interesting thing about this season was that it didn't matter where the nitrogen came from. It didn't matter if it was sitting in the soil left over from last year, from a big dump of fertiliser last year, or if it was put on this year, the effect on yield was the same. So the carryover nitrogen was as effective at promoting yield as the fertiliser nitrogen applied that year. So that's a big factor in favour of nitrogen banks as a management strategy. 2020, so these are the new results that are written up in the manual. Back to wheat, Scepter, sown in the middle of May. Again, very large response to nitrogen. So from 2.9 tonnes per hectare and extremely low protein in our control up to 4.5 tonnes per hectare in our most, and what you'd call non-limiting protein. So AH protein in our, oh no, that's still high APW, isn't it? Sorry, confused. In our, what's that? Our gung-ho yield profit treatment. So that's really the only one that got close to being not nitrogen limited. But the key thing is that our most promising nitrogen bank and what we'd consider our benchmark gold standard of yield profit at 50% probability are performing very similarly in terms of yield and in terms of profit. And that's probably the 3-year story so far, and the big learning is that our 2 best treatments are our gold standard, our yield profit, which we have calibrated and working very well at the site, and what turns out to be our environmentally appropriate nitrogen bank, this NB125. And the other thing to note is that both of these treatments apply rates of nitrogen well above the national average. So the national average is 45 kilograms of N per hectare per year, which I wouldn't mind punting is fairly representative of the Birchip district and north of Birchip. Is that a fair comment? That's about how much N would go on a non-cereal crop, so about 100 kilos of urea. So that's probably the best control. So these treatments up here, I think YP50 is putting out on average about 80 kilograms of nitrogen per year, and NB125 is about 70, I think, 60 or 70. But the good thing is that they both have a slightly positive nitrogen balance. So they're up the top of the peak for profit and they've got a positive nitrogen balance, which means you're not mining soil organic nitrogen. So you're not running down your soil organic matter and your soil organic carbon. So it's a win-win. And then if we look at the 2020 soil mineral N tests, the other positive thing is that we're recovering most of our nitrogen that's applied above our balance. So it's, doing this nitrogen balance is exactly the same as the phosphorus balance that Harm did in his exercise. It's just export in grain minus fertilizer inputs. And you can see when it goes positive, we're keeping most of that nitrogen in the soil. So it is carrying over for other crops to use. And the other good thing to note is that our most profitable treatments, so this is the yield profit 50%, and this is the nitrogen bank 125, they don't have heaps of soil mineral N in the soil. So they don't have a lot of nitrate that's prone to losses. So they're being pretty efficient. So that the field experiment's looking good after 3 years. BCG will keep it running as long as we can possibly get funding for it. But the modelling has been done over more years and in more locations, and generally agrees pretty well with what we're finding in the field experiment. So this is Birchip and using AppSim to look at different treatments. So we've got the national average over here. We've got our nitrogen bank treatments at different levels here. And then we've got yield profit here. So the treatments to focus on are YP50 is our gold standard, and over here is our environmentally appropriate nitrogen bank, and they perform very, very similarly over that time period in terms of closing the yield gap, so how much of water-limited potential yield you're achieving. And it's sort of thought that being at about 75 or 80% of water limited yield is the best spot to be if you're a grower, to take into account risk. So that's what people call economic yield, and both those treatments are there. If we then go and look at different environments, then we see the figure changes. So at Mildura, 75 is more appropriate, and actually the national average works pretty well at Mildura. Birchip we're at 125, Longeronong's 175, down at Lake Bolac we're much higher. So just making the point that the target shifts with environment. If we look at risk, both yield profit 50% and your appropriate nitrogen bank stack up really well. So this graph shows the relationship between your average gross margin and your 20th percentile gross margin. So the gross margin you'd get in a fairly crappy year. So anything that's up here in this corner has a very good return to risk ratio, and that's where you want your treatments to be. And in most of those environments, yield profit 50% is way up there, with the exception of Mildura. And at least one of the nitrogen bank treatments is in there as well. So in terms of profit and risk, yield profit and nitrogen banks are equivalent, and they're by far the best. It's only at Mildura where putting on the national average actually makes any sense. Moving to losses, which is the other aspect, the other piece of good news is that the modelling indicates that losses out of nitrogen banks are no worse than yield profit, which is where we're trying to minimise losses by managing our inputs to seasonal yield potential. So we're still getting some losses. At Mildura, we're getting some leaching losses as nitrogen rate increases because we're on a sandy soil, and Michael's going to get up me and say, what happens if you used a heavy soil at Mildura? We have heavy soils too. I'd have to say it wouldn't leach, Michael, but I can't tell you anything else. Birchip, hardly any leaching or denitrification. Longeronong, we start to get some denitrification, and Lake Bolac denitrification becomes quite appreciable, but it's no worse in the nitrogen bank compared to the yield profit 50%. Okay, so conclusions from our 3 years and our modelling thus far is that nitrogen deficiency is still a problem. That was clear from the survey results. There's still a lot of ASW and APW floating around out there, and that limitation probably applies to canola, barley, oats, or your non-legume crops. So nitrogen banks, we think, can offer a way of solving a lot of those problems. It increases profit, closes the yield gap, and it stops the decline in organic matter. And they're simple to use. They're much simpler than yield profit, but they don't give you as much information. So we don't have a lot of information about other environments, sites and seasons, and we still don't know how much we're immobilising versus losing. And I think there's a lot to be done around better managing nitrogen spatially, because there's some parts of your paddocks that are probably not nitrogen limited at all in most years, and there's other parts that will be. So these are challenges for the future. And I'll leave it at that. Thanks, Fiona.
Thanks, James. There's a couple of questions. Do you think agros and growers are time poor, or is it a lack of understanding about soil characteristics in terms of being a barrier to using yield profit?
Well, I guess like the barrier is actually taking the time to learn about soil characteristics and fiddle around until you get it right. So it's like, I think anyone can learn anything. It's just about having the time to do it is the issue. So I'd say that, yeah, being time poor is more important than being ignorant in this case.
Good answer. What long-term average wheat yield would you say the paddock you are working on? And same person, Hugh, how late can we apply nitrogen to wheat before it's too late?
I think I'd have to throw the first question to Bomber.
You went for canola, I had legume, so the wheat that I had this year was...
Now, what you reckon would be a long-term wheat yield for that paddock? A rough guess.
I suppose I've got to say 6.1.
Average.
Two and a half, three, like if you take into account the tougher years and better years, I suppose. Yeah, but we are, putting more and more nitrogen, and direct drills, come in now. So it just depends what the country. That country we sort of do more legumes on, and it's a bit lighter country in there, so we're able to push it a bit harder than some other countries. So, it might be a bit more, but if you work on that, and yeah, look, the last 2 years have been exceptional. So it always comes home anyway. Yeah, we get something anyway.
So it's fair country around that 2.5, 3 tonnes.
I think it's worth about 6,950.
An acre?
An acre. Near Kanaiboya.
How late can we apply nitrogen to wheat before it's too late? And the answer is it depends. It depends if it's going to rain or not. And so that comes down to that being able to predict the future or not. If you know it's going to rain, you can apply nitrogen to wheat right up until anthesis and you'll still get a yield response. But if it doesn't, you won't. And so that's why we say apply most of it in winter and early stem elongation, because that's the most reliable time where you'll definitely still get a yield response. But if you know it's going to rain, less of an issue. How do we get people to do more deep ends? A critical part of the strategy. I don't know. It's a tough one. We highlight that BCG has a soil sampling service and they do a really good job, and all you got to do is give them a call. Oh, Kate Madden's waving. Call Kate and she will come out and do it for you. You don't have to do anything. She does all the hard work and it's done.
Pay for it and tell her where to sample.
Yeah, you got to pay for it apparently and tell her where to sample. And that's the easiest thing to do. Just outsource it. Why were the excess N losses less in the second year? Oh, okay. So it's actually sort of 2 year versus 1 year. I think it was probably summer rain. Yeah, that big summer rain, but I don't even really know if they were losses or not because we don't have 15N, so we don't know what's being immobilised. So it's still in the system, but just gone into organic form and what's actually being lost. Any indicators for nitrogen deficiency in barley? Protein again, but the critical values are probably lower. So, I don't think anyone's done the study that I'm aware of, but probably shift it down 0.5% and you're doing okay. So if you're dropping below 10, that's probably an indication of definite nitrogen deficiency. Stop dreaming, Bomber. That's not a question, that's a statement. Does this strategy work in soils with subsoil constraints, e.g. boron? Yes, it does, because if you're on a soil with subsoil constraints, your crop won't be taking up nitrogen. If they're genuine subsoil constraints and your roots can't get down there, you'll find when you take a core, you have nitrate and ammonium accumulating at depth. And so if you measure that in your sampling, you won't need to top it up. But then that raises the issue, well, if my plants can't get it, maybe I should actually just be measuring my nitrogen bank in the I want to say rootable depth, but that's not a good thing to say in Australia. What's the plan for working out end banks in other areas? We need more money, basically, is what it comes down to either do it with simulation or experiments, but we're hoping that we can do it. We're hoping there'll be a relationship between annual or growing season rainfall and roughly the right amount of nitrogen bank. But yeah, we just need more resources to be able to do the analysis.
Got a couple of questions from the audience. Ian?
James, how does the strategy fit into rotations, and where some paddocks will go into legumes, which use rhizobia, and some just go into pastures? I mean, how do you fit that into that strategy?
The honest answer is we don't really know, because we haven't. The ultimate would be to run this experiment factorially with a rotation experiment where you're looking at with legumes or without legumes and your legume intensity. But we're thinking all you need to do is, obviously you're not applying nitrogen to your legumes, so you just ignore that for that year when you're going into the legume phase, and then measuring it coming out of that phase, and you'll probably find that in a lot of cases the nitrate is above your target value, so you don't need to top dress in that year, but you might the year after. Okay. But yeah, we need more data for that one.
Tim? And I think, Ian, you stole Anne Jackman's question. So.
Isn't that a question of lazy rhizobia, though? So if we're doing an end bank, then lazy rhizobia, so we're not getting the benefit of the pulse?
Yeah, potentially. So if you've got very high mineral nitrogen when you go into a pulse phase, your pulse crop might not fix much of its own nitrogen, but extract it from the paddock. So that's the risk. But I guess the results from 2020 showed that our most appropriate nitrogen bank didn't actually have any more mineral nitrogen at sowing compared to yield profit or even the control, really. So yeah, we're not actually getting into the situation where we might have lazy rhizobia happening, but that's certainly a risk that could happen.
A couple more questions on the screen, James.
By putting on more N, are we increasing organic matter rather than it being mineralised? Yeah, so it's really hard to measure soil organic matter. You need a lot of years of apply treatments for a lot of years before you can measure it. But in theory, if you're applying more nitrogen than you're taking off in grain or is being lost, you should actually, and you're adding a carbon source, so if you're retaining all your residue, you should in theory be building soil organic carbon, soil organic matter, as long as other nutrients aren't limiting and as long as you've got habitat in the soil for that organic matter. So there's a lot of ifs and buts there, but I guess it's definitely very clear that if you're mining nitrogen, so if you're taking more off in grain than you're putting on in fertiliser, you'll almost certainly be running down your soil organic matter. So that's definitely the case. Are there large paddock trials for this going on yet, James? No, but that's a great opportunity. So the sort of paddock scale trial that Harm talked about, this is exactly the sort of thing that you could do this on. So if anyone's interested, growers out there who have the capacity to do it, I think BCG and myself would be very interested to talk to you, because that would be a very effective way of studying it in different environments.
Thanks, James, and yeah, round of applause for James, because every year it does create a lot of discussion, because it is such a big input into our farming systems. It's important that we're thinking about it, and hopefully we can move beyond sort of gut feel, and we feel like we've got some tools and some strategies that can help us make that important decision around nitrogen. And I think the end bank, as well as the support of yield profit, is are really good things that we've got to work with. Okay, so I did manage to catch a few people at lunchtime. Not everybody ran away from me. I did get a few hard no's, and that's okay. I appreciate that. So this brings us to our last session, which is really just a wrap-up of the day and trying to capture a few farmer thoughts around their approach to the season 2021 and anything that they've taken away from today's discussions that they're thinking about applying or anything that they are going to be changing on their own farming systems. So can I ask John O'Dyer, Georgie Warren and Matt McGurk to come up and be part of the panel discussion? And Daniel Watts, I've got you on notice for next year, so you've got out of it. Yeah, you've each got a microphone on your chair, and I promise it's not going to be too taxing. But we'll start with you, Jono. Really, I guess, is there any? First of all, perhaps just let the audience know where you're farming and then your farming system. But then, just in summary, your strategy going forward for 2021, based on maybe some experiences in 2020, and then maybe how some of your thinking has been, challenged or informed by today's discussions.
In a couple of sentences.
Oh, you can. We've got a few minutes until the bar opens.
Thanks for asking me, Fiona. Jonathan Dyer, farm at Caniva down in the highly prized and highly valued West Wimmera. Feeling pretty good about season 2021 because of how good my equity is this week compared to 2 weeks ago. So we're off to a good start to the year already. Seriously though, continuous cropping, 25% bread wheat, 25% durum, 25% canola, and the rest pulses. So that's sort of what we aim for. We don't sort of change it too much year to year in terms of the crop mix. Apparently most people who are in the Wimmera Mallee had a pretty cracking season last year. At the end of July, the wheat paddock next to my house started turning up. It started going blue and wilting under all the trees, and it had heaps of frost at that point. It had all the marker signs of a drought really, and then it just started raining and had an incredible spring and really good yields. What else was on that list that you gave me
I guess the key thing, Jono, are there any major issues on your farm that you're battling or that you're working to try and overcome in 2021? Or is it just the dream country over there where everything goes right by the sound of it?
Yeah, we certainly have been blessed. The agronomic challenges to come out of this year is it's always ryegrass, right? Always weed control. Always, we push the cereals fairly hard at our place, push wheat fairly hard. So ryegrass is always everywhere and always our biggest kind of challenge, and particularly in the durum, the preems in the durum just didn't. We've had probably ongoing issues with prosulfocarb and boxer gold and stuff in the past, but this year in patches in our durum it just sort of totally kind of fell apart. So we had some fairly big blowouts, and so was very excited. We heard earlier about all the new chemistries coming through. A couple of them look like being viable options for durum, so pretty excited to give them a go this year.
Great. Well, we can come back, but Matt, your season this year, what's it looking like in terms of the plan? Has it changed based on any experience that you had last year, and any takeaways from today?
So Matt McGurk and we farm at Charlton, so mixed farming, mainly cropping with first cross ewes and cattle as well. So not quite as valuable as Caniva land, but we did have a good year last year and the one before. So probably similar to Jono, weed issue. Ryegrass is our major cropping weed, but I suppose probably biggest challenges were last year. We had a good season in 2019, managing nutrition right, particularly nitrogen. Coming to another good year last year was probably one of our challenges, which was interesting listening to James's chat there again. On the end bank side of things, that was one thing I thought today was a different strategy to just to look at a blanket number on your nitrogen across year in, year out, which is something we do with our phosphorus. We have a bit of a guide what's in the paddock and try to match our removal to keep it constant. So that was something I thought was definitely a take-home message that I'd be keen to have a look at on our test versus and crops. Obviously, managing, we've always had that thoughts in the back of our head about haying a crop off, and certainly in regards to barley and those things. But certainly that was one thing I thought we could implement if we can manage to buy urea later on, I suppose. What else did you have there, Fiona? You wanted me to...
Oh, no, look, I was really just thinking, is there, and you've probably touched on it, the takeaways from today's discussion, the end bank, anything else that you've got as a takeaway from today?
There's, I suppose, every time you listen to a presenter, they're obviously invested in their projects and they're very knowledgeable, and you're listening away, and then you understand that everything they come up with is that many more questions. I suppose that's with farming. I think it was Waffle said it was a bit of a game, and you've got to try your best at it. And it's one of those things that every presenter, their work's really, really intriguing. And then you look at it, how's it fit into my system, and they're trying to deal with the issues that we're dealing with as well to make it fit in. So there's plenty of take-home messages throughout the day. Thanks, Fiona. Okay, Georgie from Colgoa. Your challenges from last year, how they're influencing your decisions this year, and any takeaways from today?
Thanks, Fiona. I farm with Dad up the back with the teenagers. Oh, is he asleep? No. So we have, well, people are laughing because they think we have a pretty volatile relationship, but we think of it more as constructive and upfront. So last year, matching nutrition was probably the hardest part of our business because everyone that knows Dad would have heard him say 50 times, there's been more money wasted on urea in the Mallee than has been gained. And like Tim's dad and like James's parents, he's just afraid, he must have burnt a few crops on the highway in his time as well. So last year, matching urea and keeping it up was our biggest challenge. Until James spoke, I thought we'd nailed it because everything mostly went APW, but now I hear that means we've underdone it. So that's one thing for next year. Not unlike Jono, land prices around Colgoa have gone well north of 2,000 an acre now, which is surprising us. So that's what I think Dad and I, our farm isn't growing, but we're working on now treating our farm like it's worth 2,000 an acre. So we're starting on gypsum spreading and just things to keep improving it. Also pretty good at ryegrass as well.
So any new chemistry being used on your farm this year, Georgie?
Yeah, I used Callisto last year and that nearly smoked a crop, so I'm going to steer away from that one. But I've written down Ultro and I'm going to look into it further about using it on chickpeas.
What about you, Matt? Any new chemistry?
We always have I suppose we like to think it's a robust herbicide regime. There's always something new and different, I suppose, that pokes its head in. So there's always different ones to try.
Any of you managing any herbicide resistance issues on your farms?
Yes.
Can you elaborate, Jono?
Yeah, well, there's probably been we've been getting a resistance test done for 3 or 4 years, and they've sort of been coming back kind of low levels of glyphosate resistance. I mean, there's all the usual ones that everyone has, but kind of the ones we're more scared about. Glyphosate's one we're more scared about, and then we took on a block at the start of last year, and it came back as what was it? Was it no clethodim and no Indivix, or was it the other way around? Yeah, 100% resistant to label rates of clethodim and 50% resistance to label rates of Indivix. So, it's good to have a challenge and learn things.
Are you thinking about maybe investing in some of the weed seed at harvest mechanics, like the Terminator or the Destructor technology?
Yeah, we have. So we've had one Terminator on one. We've got 2 green headers. So we put a Terminator on one of them 3 harvests ago now, just because we saw the potential of the technology for our region and kind of really wanted it to work, but wasn't sure if it was kind of ready for the prime time. And then just prior to harvest last year, we decided it was, and so we got the second machine fitted up. So just on the first harvest with 2 Terminators, and so early days, but yeah, pretty hopeful with how that's going to help us out.
And Matt, your challenges with herbicide resistance?
Yeah, so like most farms, we levels of resistance for multiple years, glyphosate across the board with ryegrass, and managing it. We haven't got a terminator. We've probably tried managing it more with a rotation. So we grow oat and hay for export, vetch hay. We enable the Charlton feedlot, so we do a green chop silage program for them. So between those few crops we're removing seeds before they manage to set and aim to get 100% control with herbicides or mowing. We're also chaff lining off the header. Whether we're reducing, we're certainly concentrating the seeds in those paddocks, but probably more targeted with our rotation. In particular, glyphosate resistance there's one soil type on our farm that was quite bad with it, which I think we're on top of it now. It probably took one paddock we had 5 years straight without taking it through to grain, so which was in some years was the most profitable paddock on the farm, which is funny as it sounds, but yeah. So it's a battle.
Yeah, it sounds like it. Georgie, any herbicide resistance issues at Colgoa?
Not tested, but pretty confident we've got a few. But just like Matt was saying, we've got what was my dirtiest paddock and probably still is. It'll be in its 3rd year of hay this year. Last year was its 2nd, and it yielded really well of oat and hay, but I think it still had half a tonne to a tonne of ryegrass in that bale. So it'll be interesting to see 3rd year in a row and then see what happens this year. It might go into canola next year, but just managing it with hay, rotation. Wouldn't mind a chaff deck, not mechanical enough for a seed destructor yet. 5 years' time, they might be a bit simpler.
I love it when there's questions coming from the audience. So for Jono, any temptation to drop 10% area out of crop to help manage ryegrass?
Yes and no. So we have a rough rule of thumb, I guess, on the farm that every year kind of the worst paddock on the farm gets left out for vetch, either just sow it early and then opportunistic haymakers, I guess. Last year we just was the one with the resistance, so we just dissed that in. We had our planning meeting for this year last week, and so that was with 2 of the paddocks, the Durham paddocks that had the blowouts, was the big discussion about, or do we leave one lot out or both, or so we've kind of gone 50-50, so we're going to leave one of the paddocks out that's really bad to vetch, and so that will get left out, which will be roughly 5%, so it's not the 10 that the question suggested. But the question that I've got now with the terminators is if we can grow something like beans, and then, because we're going to, all the preems with them, and then we're going to desiccate them, and then, because they're beans, we're going to shave them off at ground level and put everything through the terminators, is can I have my cover crop and harvest it too? So kind of a trial this year.
Great. Sounds interesting. We might have to get you back next year to talk about it. Look, I appreciate that we have gone well over time, but I would like just to give each of the panellists any last take-homes from today.
That we can sow vetch earlier than we thought. That was really helpful, the hay yield business today.
My biggest take-home was the end bank, trying to just, rather than crystal ball every autumn, to just have a figure and have a go at that.
Yeah, similar on the end bank thing. That's probably, apart from the weeds thing that I've talked about, that's the other big challenge at our thing that generates the most discussion at our place. And I thought we pushed it fairly hard on a few paddocks, but if we was to follow the rules of thumb that James presented earlier, there's, we could probably go harder in some spots. So it's a challenge.
Great. Look, thank you very much. Round of applause for Jono, Georgie and Matt. Definitely, appreciate you offering to wrap up the day. Look, that really brings us to the end of our Trials Review Day. We really hope you've enjoyed the discussion. We absolutely have appreciated you being here. We certainly have enjoyed having, as I said at the top of the day, an opportunity to catch up face to face. It is really good to be able to share our results with you and have the opportunity to talk about it and, as I said, discuss what the impacts are for your farming businesses and the decisions that you're going to make this year. So we're wishing all our members all the best. So I guess just on that, BCG really do value the member feedback that we receive, and we thank all of our members who say yes to hosting sites every year, to answering surveys, to being part of workshops that we're running. And we really hope that your involvement in all of those activities provides value to your business. And yeah, as I said, we really, really appreciate the support that you give us and the input and the feedback that you give us. I'd like to thank the staff for today. It's a great job. It was managing a lot of things in uncertainty. We weren't sure what Daniel was going to tell us on Wednesday, whether we could go ahead or whether we were going to be, beaming in online. But as I said, we're really pleased that we were able to meet face to face. And look, for all of those people who have joined us via live stream, we hope you've found the interactive sessions really positive, and we thank Power AV for being our backup support too, making sure that all the screens are working and the microphones are working. I think it makes the day a really positive experience for everyone when you can see and you can hear, and it does make a big difference. So thank you very much. Just on our staff, I wanted to introduce a new staff member. So we've got Tariq Girardi, who's actually started, or Rick, who started with us 3 weeks ago. So jump up. Recent graduate from La Trobe University, Ag Science, so one of James's graduates. So welcome to BCG. We're really pleased to have you part of the team. So if you see Tariq around, then yes, make him feel welcome. And also James Taylor. I'm not sure if James is here. So James will be joining the team. He's a Melbourne University graduate 2 years ago. He's been working for the Meat and Livestock Association in Armidale for the last 2 years. So we're really glad to be welcoming him to the team, as well as another research agronomist. So thanks, James, and welcome. And finally, thanks again to all our sponsors and our diamond partners particularly. And also too, a special mention at the very end of the day is that we've got the bar open. There's a tab from BCG, but I also should mention there's some mill beer, which is provided by the Seed Terminator team. So if you want to try a mill beer, Ash will be able to serve them over the bar. The other thing is, I mentioned it earlier, there will be evaluations being sent out during next week. And so we please, as I said, ask you for feedback. We really appreciate it. And finally, thank you to the National Centre for Farmer Health, who have been here all day. I haven't had a chance to catch up with you, but I hope some farmers have come and made themselves available to you to, give themselves a once-over. So thank you for being part of our day. We really, really appreciate it. And thanks for having a long association with the Birchall Cropping Group. Tom, have I missed anything?
No, you got it all. Well done, Fiona.
Great, thanks. I usually manage to forget something, but have a great, rest of the season. We hope to see you at a few BCG events throughout the year, and stay around and have a drink, and safe travels home.